Chapter is called nomenclature. This is a pretty hard chapter. You do have to practice to get better at this. So I suggest a lot of practice. Please let me know if you need some more. I can find you some. So what we're going to learn how to name in this class is called IUPAC naming. That stands for International Union of Pure and Applied Chemistry. These are the things you're going to learn how to name by the end of this lesson. More common names for compounds are not what we're learning. For example, we're going to learn calcium oxide, but we do not name it lime, and sodium hydroxide, we do not call it lye. So you will be learning the international system. So anywhere you go, you'll be able to name a compound. Now this is a review from last chapter. We know the charges of group 1 is +1, group 2 +2. We know +3. We know this one to be plus or -4. We won't really use that too often. -3, -2, and -1. So we're going to continue to use that in our formula writing and naming. So metals actually always lose electrons. So literally they're given to the nonmetal when they form their ionic bond, and they become cations. Cations have positive charges. You can see the positive there. So we are looking at potassium, and potassium is K. Again, a review. You can see potassium here. It is in the group 1 column, so we are going to see that +1 charge. That means it loses 1 electron because it has 1 more proton. We call this potassium ion. So it becomes an ion. So this is the atom, and this with the plus sign is the ion. Okay, so it has to lose or gain electrons. The next one is magnesium, but that is the atom. This +2 charge means it loses 2 electrons, and it becomes magnesium ion. And then we have aluminum, loses 3, and again you can see aluminum in the +3 column. And so we're going to call that just aluminum ion. Now, we're going to talk about nonmetals. Nonmetals actually gain the electrons lost by the metals, and they become anions, we call them. So anything with a negative charge are called anions. And we can use those same column numbers to figure out how many electrons are gained. So fluorine, F, let's go ahead and look. So we're looking at F, Cl, Br at this point. If we go back to our periodic table, we can find that here we see F, we see Cl, we see Br. So that is all in the +1 group. So let's go back down here. So fluorine gains 1 electron, and that becomes F -1. Same with chlorine and bromine. They both gain 1 as well because they are in the same column. We call those the halogens. And again, I'm getting these numbers from our -1 column. So we're going to actually change the ending of anions to "ide." Okay, so when it becomes an ion with a charge, it becomes "ide." So this is fluoride. Okay, this is chloride. And this is bromide. You do not change the ending of a metal. You change the ending of a nonmetal when it becomes an ion. So if you look back on your periodic table, oxygen is going to gain 2 electrons. That makes it O -2, and nitrogen's in the column that gains 3, and that becomes N -3. And again, I'm going to change the ending to "ide." Now, we did this a little bit before, formula writing, so we know the charges. So I like to write the charges up above. Then I say we crisscross them and bring them down. So it becomes Na1, Cl1, and again, you do not have to write the ones. You can just leave the ones off, but if you want to write them, that's not a problem. This one's a +2, -1. So go ahead and pause the video and try the others on your own. Remember, when these are both 2s, they cancel each other out to become MgO. So that 2 comes down. Remember, we do not bring the plus or the minus down. We only bring the number. Okay? All right, moving on. Now, this is going to be available on all your exams. I'm going to give you a copy in class, and this is all a bunch of different cations, which in this case the cations are these two. So these are the positive components, and the rest are anions, and that's all the red ones here, okay? And again, cations just mean it has a positive charge, like these do, and the rest have negative charges, okay? So again, you're going to get to use this. What you should be using in this is you want to look at the formula and you want to look at the names. You're going to be using both of those, so make sure you're familiar with them. All right, now we are going to formula right now with that list. So we call everything on this list a polyatomic ion. Poly meaning multiple, atoms meaning multiple atoms, and they're ions, okay, because they have a charge. So we are going to do the same thing. We're going to bring down our charges. So Na is a +1, NO3 is a -1. So we go ahead and write it like that. Now, I want you to understand that anything written on this list that you see up here, they're what I call stuck like glue. So these things, the N, the O, the 3, will never separate. You're never going to bring or move the 3 anywhere. If any number comes down, it's going to be brought outside. I'm just going to show you an example here. So let's say I was bringing a number down. I'd put it on the outside. Okay, you never mix it in between. So that is obviously not the case with this one, but I do want to just show you kind of how that would work. Okay, so we'll do some more examples here. Again, you are crisscrossing your charges. So the 2 and the 1 crisscross. So SR, and then the 1 would go down here. Again, you don't have to write that. And then this is N3, and that is a 2 charge. Okay. So again, you don't have to show that 1, but I am just showing you. All right, and then that 3 comes down, and the 2 comes down, so Fe2CO3. Now, if you're bringing a second number down, you need to add parentheses, because this 3 actually goes to everything in here. It doesn't just go to the outside thing, okay? So let me erase that and rewrite that nicer. Okay, so you bring that 3 down, okay? So getting used to writing parentheses is very important. So we have a 1 and a 2, so this becomes NaSO4. And put the 2 down there to crisscross it. Now again, if you want to write parentheses and put a 1 down here, you're fine to do that. It's uncommon, but it's not wrong. Okay, I prefer to not have it because it kind of makes it a little bit busy, and I prefer to write it like that, but again, up to you. So Mg2SO4 2, and again, this is fine, but it's preferable since they're both 2s, they cancel each other out. Okay, so you actually don't need to write them. They should actually be a little closer as well. Okay, so MgSO4, and the last one is the 4 and the 2. Now I'm hoping you see this 4 and this 2 are going to be able to reduce themselves, so let's write it what it would be without the reducing so far. Okay. If this is a 2, and this is a 4, they actually would cancel, so this one would become just a 1, and this would become a 2. Remember, this will never, ever change. We do not reduce those numbers. If this comes as a group, it does not change. The only thing you do is put parentheses around it. So I'm going to go ahead and rewrite this as PbCrO4 with a 2 outside. Okay? All right, naming simple ionic compounds. So again, ionic, I'm going to continue to remind you, ionic is a metal plus a nonmetal. We now know that to be a cation plus an anion, so a positive charged thing and a negatively charged thing coming together to create an ionic bond. So naming a simple ionic salt, this word salt literally just means ionic compound, so metal and nonmetal, involves the addition of a cation, okay, from the left side of the periodic table, and an anion from the right side. We now know left is metals, right is nonmetals. So to write the name, and we've actually already done this a little bit, to name the first element, you name the cation. To name the second element, you change the ending to "ide." Okay, and here's some examples of all the ides. Again, you only do ides for non-metals. You do not ever change a metal ending to anything. Okay, so let's go ahead and do this. So we see the Na and we see the Cl. So the first thing, this is the cation, this is the anion. So we're going to name this sodium. And then this is the anion, we're going to name it chloride. Okay, so that IDE ending. So sodium, you name the metal, you don't change anything. You name the non-metal and you change the ending to "ide." Okay, so why don't you go ahead and pause this and hopefully you can do the rest of those. The next one here is lithium fluoride. Now these numbers are going to start to confuse you, but I want to remind you that when you put them together, they crisscross. So I want you to start seeing that they uncrisscross when they separate. So if I have K2O, I want you to start seeing this as actually K plus 1 and O minus 2, okay? Because you're going to need to know that very soon. So you may see it as K2O, but I want you to think before you had K2O, you had a K with a plus 1, which would have gone down here, and the minus 2 crisscrossed, okay? So I want you to know where these little numbers come from. But let's go ahead and name this. So we're going to name this potassium oxide. Okay? And again, these charges, I want you to see, and if you need to draw these lines and pull them back up, go ahead. Remember, the first one is always plus, and the second one is always negative. Okay, you're going to need to start seeing that. So this one's called, same thing, magnesium nitride. Okay, so hopefully naming ionic compounds, simple ones, is not too bad. Now this is where it gets a little fishy here. So this is a little bit different. It's still ionic, metal and non-metal, cation and anion, but it's polyatomic. So you're going to want to refer to that list that I'm going to give you in class. Okay, and again, you will be provided with that the whole time. Now, why that's helpful is you need to be able to see this compound. Okay, and I want you to take a second and look at your list, and I want you to find the thing that has the CO3. So if you look on your list, you will see the CO3 is actually CO3 minus 2. Again, you don't have to memorize this. I want you to be able to see this. So that is where this 2 comes from. It came from the CO3. Now, I also want you to remember K is in the group 1. Group 1 is always a plus 1. Okay? Always. Now, again, why don't you see the 1 down here? Because you don't show it. Okay? So this 3 did not come from the K. K's never change. They're in group 1, so they're going to be always a plus 1. Now, why do you need to see this? Because you need to know that the name of it is potassium, okay, carbonate. And again, you will see that word carbonate associated with this CO3 minus 2. Okay? So you need to look at this second half, or the first half, depending on which one looks a little bit confusing. Find the thing that matches, and I like you to write it above, because you're going to need that as we move through here. So again, this one's NO3, and if you look at your list, that's a -1. Where did this 2 come from? The Mg, because Mg is always plus 2. Okay, I like to know those, and makes it easier to name the compound. This is magnesium, and it's nitrate. Now again, this ending is different, right? These 8's endings are different than "ide." Okay, you have to know that if it's by itself, a single element as the second thing, that is "ide." But when it's a group called a polyatomic, it's 8. Okay, so I want you to find SO4 in your list. I want you to see SO4 is SO4 minus 2. SR, okay, if you look where SR is strontium, it is in group 2. Group 2 always, always, always is a plus 2. Okay? So you have to remember, why are none of these 2's shown? Because they cancel out. If you start doing this from the beginning, I promise when we get to a harder part of naming, it'll be a lot easier. So please continue to practice that. All right, again, I want you to find something that looks like ClO4. If you look on your list, it's ClO4 minus 1. If you look where sodium is on the periodic table, it's plus 1. We're going to name that sodium. And the name of ClO4 minus 1 is perchlorate. So the name of this compound is sodium perchlorate. All right, now, this one looks a little fancy here, but this first part is actually on your list, and this second part is actually on your list. Remember, if it's in the beginning, it's plus. Plus at the beginning, always negative the second one. So if you look on your list, you're going to find something NH4. It's NH4 plus 1, and this is NO3 minus 1. Okay, so again, use your list. We're going to name them separately. Ammonium nitrate. Okay, All right, last example with this set. Again, I want you to find your list. You may remember that as our first example. We know that is CO3 minus 2. I want you to find calcium on your periodic table. It is in group 2 again, and that is a +2 charge. Where are the 2's? They have canceled each other out, okay? So we're going to name this calcium carbonate. Again, that carbonate comes from the polyatomic list. All right, now this is where it gets a little bit more confusing. So we have already identified group 1 to be +1, group 2 to be +2, +3, plus or minus 4, -3, -2, -1. Now, you probably have noticed that we have not talked at all about this middle section, okay? These are called transition metals, okay? And transition metals have multiple charges, meaning they can change. They can change their charge. So we have to use our context clues to figure out the charge. Now, to indicate the charge, we are going to be using Roman numerals, okay? So just a quick review of Roman numerals. We have 1, 2, 3, 4, 5. Sorry, that's supposed to be a V. 6, 7, 8, and then we have 9, and we have 10, okay? So make sure you know those so that you can utilize them. So when we're looking at these, again, the charge is indicated by the Roman numeral that you write next to it, okay? So it's not only in the middle, but it's also some of these sides, so you have to know these as well. All right, again, you don't have to memorize the charges. You use your context clues. So let me show you an example here. What we're working with is CuCl2. This is what I mean by you have to use your context clues. Remember, Cu joins with Cl, right? Cu is found right here in the middle. It's a transition metal, so the charge is not assumed, okay? So this first one's a plus something, and this one's a minus. Now, one of them you know chlorine is, I believe it's right here, and so it is a -1, always. So what we have to do is uncrisscross, so that this 2 actually came from the Cu. And to do that, we write copper 2 chloride. Okay? So you have to write the Roman numerals in the name. You have to, because they are not the assumed charges. They always change. So again, I want you to uncrisscross this. I want you to look on your list, and I want you to find SO4. SO4 is a -2. Then you assume you know where this 2 came from. Now you have to assume this 3 then came from the Fe. So this is an Fe plus 3. Again, the first charge is always a plus. The second is always a minus. I just want to remind you, any ionic bond, plus and minus. First is plus, second is minus, always. So this is iron, Fe, 3 sulfate. So nothing really changes. You just need to figure out the charge. And then if you have a Roman numeral, you need to use that if you're writing a transition metal. So Sn is tin. That 4 came from that. The NO, when you look it up, the NO3 is a -1 charge. The Sn, therefore, is a +4. This is tin 4 nitrate. And then our last one down here is TiO2. This is a difficult one. So let me show you how this would work. You would assume this 2 came from the Ti and this came from the O. But I need you to look and find what the charge of O is. O is always, always, always a -2. I believe it's maybe right here. Just the no, actually, not the 2. So that is a +2 column, okay? So what does Ti have to be to reduce to have a 2 down here? Okay? It's actually going to be a 4. So this is going to be titanium. So sometimes you have to use your clues. Oxide. That's probably as hard as that gets. Okay? I'm going to end half the video for the chapter here and continue video 2 to watch the rest.